Hi, this is Mahadev Das. Welcome to my YouTube channel 7Tech. Today I will discuss about types of failure of shallow foundation. Basically in this video we will learn under the subtopic of what is shallow foundation and types of failure of shallow foundation and key features of each type of failure of foundation and IS guideline, basically IS 6403 guideline to determine the bearing capacity. Which method should be followed to find out the bearing capacity value? Okay. So now what is shallow foundation? A foundation whose width is greater than its depth. Okay. And the shearing resistance of the soil in the sides of the foundation is generally neglected. Means in shallow foundation the side of the foundation and due to frictional or any other point of view that should be neglected in shallow foundation. Okay. Now what are the types of failure in a shallow foundation? Now a bearing capacity failure or shear failure is defined as the failure of the foundation that occurs when the shear stresses in the soil exceed the shear strength of the soil. It can be grouped into three categories. One is general shear failure, and second one is local shear failure, and punching shear failure. Now what is general shear failure and what are the features of general shear failure? The general shear failure is characterized by rupture of the underlying soil followed by bulging of soil surface around the footing. Okay. Now in the field condition, the soil is often heaped up on only one side of the footing followed by tilting of the structure. This is actually the structure. The structure will be tilted in general shear failure. Okay. And the failure surface are well defined or well formed in the general shear failure. This is actually the heaped up of the soil surfaces around the footing. And a general shear failure occurs in the soil that are in dense or hard state. Okay. And load versus settlement graph. This is actually the load versus settlement graph. And in this graph, if we plot this load versus settlement graph, distinct point or distinct load at which the foundation fails, that is very clearly shown. Okay. Next one is key features of local shear failure. In local shear failure, there is a significant compression of the soil under the footing and failure planes are not fully formed. Okay. And this type of failure generally occurs in the medium dense or clay soil of medium consistency. Okay. General shear failure occur when the soil strata is hard, but in local shear failure occurs a medium dense sand or clay soil of medium consistency. In load settlement plot, there is no distinct point that defines the ultimate load, but in general shear failure there is a distinct point. But there is a distinct point. This is actually the distinct point to define the ultimate load. Okay. But in local shear failure there shall not be any distinct point, and the ultimate bearing capacity is not clearly defined in the load versus settlement curve. Okay. Now punching shear failure. The key features of punching shear failure is the ultimate bearing capacity is not clearly defined in the load settlement curve. Okay. And this is also not clearly define the ultimate load, and there is no heaving the soil around the perimeter of the footing. Okay. And the ultimate bearing capacity is not well defined for punching shear failure. Okay. And punching shear failure will also occur in a soil of low compressibility if the foundation is located at the considerable depth. In general, the mode of failure depends on the compressibility of the soil and the depth of the foundation relative to its breadth, and the ultimate load is often defined as the load settlement at which the first major non-linearity starts. Okay, this is actually the load settlement curve, and in this plot we have understood that this is actually the non-linearity in this bearing capacity in this case is this point. Okay, now this is very important, and guideline we will understood that which method should we follow to calculate the bearing capacity. Okay, there is three parameters. One is a relative density or density index, another is void ratio, and the condition of the soil, and method. What is the method should be analyzed to determine the bearing capacity. Okay, now when the relative density is greater than 70% and void ratio is less than 0.55, means it is a dense soil, and in that case we will calculate the bearing capacity in general shear failure by applying the general shear failure formula as per IS 6403. And when the relative density index is less than 20%, means it is a loose soil, and the void ratio is greater than 0.75. At that time we will consider to find out the bearing capacity is local shear failure formula. Okay, as well as punching shear failure. And when the soil condition is in between these two, means medium, at that time we will interpolate this 1 and 2. Okay, now thank you everyone, and if you like this video, please share and subscribe. Thank you once again.